Welcome to GCP Load Balancing. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with a focus on networking. Today, we're going to demystify Google Cloud Platform's load balancing options. If you've ever felt overwhelmed by the sheer number of load balancer types and configuration options in GCP, you're not alone. The load balancing landscape in GCP can be confusing because there are multiple types, each designed for specific use cases, and the naming conventions don't always make it immediately clear which one you need. In this presentation, I'll walk you through every load balancer type available in GCP, explain when to use each one, and clarify all the configuration options you'll encounter. By the end, you'll have a clear mental model of GCP's load balancing hierarchy and be able to confidently choose the right load balancer for your needs. We'll start with the big picture, understanding how GCP categorizes its load balancers, and then dive deep into each type. I'll show you real configuration examples, explain the key decision points, and provide you with a decision tree that will make selecting the right load balancer straightforward. Let's begin by understanding the fundamental categorization that Google uses for its load balancers. The load balancer landscape. Google Cloud organizes its load balancers along three primary dimensions: scope, which is global versus regional; traffic type, which is external versus internal; and protocol layer, which is layer 4 versus layer 7. Understanding these dimensions is crucial because they determine which load balancer types are available for your use case. The scope dimension determines whether your load balancer can distribute traffic across multiple regions, which is global, or within a single region, which is regional. Global load balancers use Google's premium network tier and Anycast IPs to route users to the nearest healthy backend, providing excellent performance and availability for worldwide applications. The traffic type dimension distinguishes between external load balancers, which handle traffic from the internet, and internal load balancers, which handle traffic within your VPC networks. This is a fundamental architectural decision that affects security, networking, and cost. The protocol layer dimension refers to the OSI layer at which the load balancer operates. Layer 7, the application layer. Load balancers understand HTTP/HTTPS and can make routing decisions based on URLs, headers, and other application-level data. Layer 4, the transport layer. Load balancers work with TCP/UDP and are protocol agnostic, making them suitable for any TCP or UDP-based application. As we'll see, not all combinations of these dimensions are available. For example, there's no global internal load balancer, and certain features are only available with specific combinations. This is where much of the confusion arises, but don't worry, we'll clarify all of this. Now let's look at all 7 load balancer types in one comprehensive view. This is crucial to understand. Google Cloud Platform offers exactly 7 distinct load balancer products, not variations or modes of a single product. The 3 global load balancers are all external facing. The global external HTTP/HTTPS load balancer is for web traffic and APIs. The global external TCP proxy load balancer is a completely separate product for non-HTTP TCP traffic like databases or custom protocols. The global external SSL proxy load balancer is yet another separate product, specifically for non-HTTP encrypted traffic that needs SSL termination at the edge. A common source of confusion is thinking that TCP proxy and SSL proxy are just configuration options within the HTTP/HTTPS load balancer. They're not. Each uses entirely different proxy resources. When you create an HTTP/HTTPS load balancer, you use target HTTP proxies or target HTTPS proxies. For TCP proxy, you use target TCP proxies. For SSL proxy, you use target SSL proxies. These are mutually exclusive. You can't convert one to another. The regional external options include the regional external HTTP/HTTPS load balancer for cost-effective regional web applications and the regional external network load balancer for high-performance TCP/UDP traffic that needs client IP preservation. Finally, the two internal load balancers, HTTP/HTTPS and TCP/UDP, are always regional. There's no such thing as a global internal load balancer in GCP. This table view makes it clear that we're dealing with 7 distinct products, each with its own use cases and configuration requirements. Let's dive deeper into the 3 global external load balancers. Remember, these are 3 completely separate products, not variations of each other. Each serves different protocols and use cases. The global external HTTP/HTTPS load balancer is the most feature-rich option. It operates at layer 7 and provides advanced traffic management capabilities including URL-based routing, header-based routing, and traffic splitting for canary deployments. This load balancer integrates tightly with Cloud CDN, Cloud Armor for DDoS protection, and Identity-Aware Proxy for authentication. It's the go-to choice for modern web applications and APIs. The Global External TCP Proxy Load Balancer handles non-HTTP TCP traffic at Layer 4 but with global scope. It terminates TCP connections at Google's Edge and establishes new connections to your backends, which allows for global load balancing of TCP traffic. Common use cases include global database connections, custom TCP protocols, and legacy applications that need global distribution but don't use HTTP. The Global External SSL Proxy Load Balancer is similar to the TCP proxy but specifically handles SSL/TLS traffic. It terminates SSL at Google's Edge, which offloads encryption overhead from your backends. This is useful for non-HTTP encrypted protocols like MQTT over TLS or custom encrypted protocols. The key point is that you choose between these 3 based on your protocol needs. You can't start with one and change it to another. They are fundamentally different products with different configuration paths and capabilities. Regional External Load Balancers. Regional external load balancers operate within a single region and are generally more cost-effective than their global counterparts. They're perfect when your users are concentrated in specific geographic areas or when you want to optimize costs while still providing external access. The Regional External HTTP/HTTPS Load Balancer is a newer addition to GCP's load balancing family. It provides Layer 7 load balancing within a region and supports most of the same features as the global version, including URL maps, SSL termination, and Cloud Armor. The key difference is that it doesn't provide global anycast IPs or cross-region failover. It's ideal for regional applications that need advanced Layer 7 features but don't require global distribution. The Regional External TCP/UDP Network Load Balancer is a pass-through Layer 4 load balancer. Unlike the proxy-based load balancers, it doesn't terminate connections, it simply forwards packets to your backends. This makes it extremely fast and suitable for applications that need to see the original client IP or handle protocols like QUIC. It supports both TCP and UDP traffic and can handle millions of requests per second. When choosing between global and regional external load balancers, consider your user geography, availability requirements, and budget. Regional load balancers can use standard network tier, which significantly reduces egress costs compared to the premium tier required for global load balancers. It's worth noting that you can start with a regional load balancer and migrate to a global one later if your needs change, though this requires some planning and potential downtime. Choosing the right load balancer. With so many options, choosing the right load balancer can feel overwhelming. Let me walk you through a systematic approach to making this decision. The key is to answer a series of questions about your requirements, which will naturally lead you to the appropriate load balancer type. First, determine if you need external or internal load balancing. External means traffic from the internet, while internal means traffic within your VPC. This immediately cuts your options in half. Next, consider your geographic requirements. Do you need global distribution with automatic failover across regions, or is regional availability sufficient? Global load balancing requires external load balancers and a premium network tier. Decision tree. Navigating 7 load balancer choices. Now let's walk through the decision tree that will help you choose the right load balancer from the 7 available options. This systematic approach eliminates confusion by asking the right questions in the right order. The first question is always, is your traffic external, from the internet, or internal, within your VPC? This immediately cuts your options. If it's internal traffic, you only have 2 choices: internal HTTP/HTTPS or internal TCP/UDP load balancers, both of which are regional only. The decision between them is simple. Do you need layer 7 HTTP features like URL routing? Or are you load balancing TCP/UDP traffic like databases? For external traffic, the next question is, do you need global distribution or is regional sufficient? This is a critical decision that affects both functionality and cost. Global load balancers provide worldwide distribution with anycast IPs but require premium network tier. Regional load balancers are more cost-effective and can use standard network tier. If you choose global, you have 3 distinct options. For HTTP/HTTPS traffic, use the global external HTTP/HTTPS load balancer. For non-HTTP traffic, you need to decide, is it plain TCP or SSL/TLS encrypted? Plain TCP uses the TCP proxy load balancer, while SSL/TLS traffic uses the SSL proxy load balancer. Remember, these are 3 separate products, not modes of one product. If you choose regional, the decision is between HTTP/HTTPS traffic, which uses the regional external HTTP/HTTPS load balancer, or TCP/UDP traffic, which uses the regional external network load balancer. The network load balancer is unique because it's pass-through, preserving the client IP address. This decision tree makes choosing a load balancer straightforward. Just answer the questions: external or internal, global or regional, what protocol, and you'll arrive at exactly one of the 7 load balancer types. Advanced features and best practices. Let's explore some advanced features and best practices that will help you get the most out of GCP load balancers. These features can significantly improve your application's performance, security, and reliability. Cloud CDN integration is available with HTTP/HTTPS load balancers and can dramatically improve performance for static content and even dynamic content with proper cache headers. You can configure cache modes, TTLs, and cache key parameters. Remember that Cloud CDN requires premium network tier. CloudArmor provides DDoS protection and WAF capabilities for HTTP/HTTPS load balancers. You can create security policies with rules based on IP addresses, geographic locations, or request signatures. Pre-configured WAF rules protect against common vulnerabilities like SQL injection and XSS attacks. For high availability, always distribute your backends across multiple zones within a region, and for global load balancers, across multiple regions. Use managed instance groups with auto-healing and auto-scaling to automatically handle failures and traffic spikes. Configure connection draining to gracefully handle backend maintenance. Network endpoint groups, or NEGs, offer more flexibility than instance groups. Zonal NEGs allow you to specify IP addresses and ports. Internet NEGs enable you to use external endpoints as backends, and serverless NEGs integrate with Cloud Run, App Engine, and Cloud Functions. Hybrid NEGs allow you to include on-premises endpoints. Monitor your load balancers using cloud monitoring metrics and logs. Key metrics include request count, latency, error rate, and backend utilization. Set up alerts for anomalies and use cloud logging to debug issues. Common scenarios and solutions. Let me walk you through some common scenarios and the recommended load balancing solutions for each. These real-world examples will help you understand how to apply what we've learned. For a global web application with users worldwide, use the global external HTTP/HTTPS load balancer with Cloud CDN enabled. Deploy backends in multiple regions. Use URL maps to route traffic to the nearest healthy backend, and enable Cloud Armor for security. This provides the best performance and availability for global web traffic. For a microservices architecture within GCP, use regional internal HTTP/HTTPS load balancers for service-to-service communication. Each microservice gets its own internal load balancer, providing service discovery, load distribution, and health checking. Use serverless NEGs if you're running services on Cloud Run. For a gaming application using custom TCP protocol, use either the global external TCP proxy load balancer for worldwide players or the regional external network load balancer for regional games. The choice depends on whether you need global distribution and can tolerate connection proxying. For hybrid cloud scenarios where on-premises applications need to access GCP services, use regional internal TCP/UDP load balancers. Configure them with hybrid NEGs that include your on-premises endpoints, enabling seamless load balancing across your hybrid environment. For cost-sensitive regional applications, use regional external HTTP/HTTPS or network load balancers with standard network tier. This can reduce costs by 24 to 40% compared to premium tier while still providing good performance for regional users. Let's summarize the key takeaways we've learned about GCP load balancers. The key to mastering GCP load balancing is to understand three dimensions: scope, which can be global or regional; traffic type, either external or internal; and protocol layer, which can be L4 or L7. These dimensions determine which load balancer types are available and appropriate for your use case. For external traffic, you have 5 options. 3 are global: HTTP/HTTPS, TCP proxy, and SSL proxy. The other 2 are regional: HTTP/HTTPS and network. Global load balancers provide worldwide distribution and high availability but require a premium network tier. Regional load balancers are cost-effective for geographically concentrated users. For internal traffic, you have 2 regional options: HTTP/HTTPS for Layer 7, and TCP/UDP for Layer 4. These are essential for multi-tier architectures and microservices. Remember that internal load balancers are always regional. There is no global internal load balancer. When choosing a load balancer, start with the fundamental questions. Is the traffic external or internal? Is the scope global or regional? And is the protocol HTTP/HTTPS or TCP/UDP? Then consider your specific requirements for features, performance, and cost. Use the decision tree we have provided as a guide. Remember that load balancers are just one part of your overall architecture. Combine them with other GCP services like Cloud CDN, Cloud Armor, and Cloud Monitoring to build robust, scalable, and secure applications. And always follow best practices. Distribute backends across zones, use health checks, enable connection draining, and monitor your metrics. Thank you for your attendance. Please consider subscribing to the channel.